In this episode, I want to talk a little bit about resolution, what you finally need for a panorama. And I have created here this grid. And when I take a look here, image size is 1600 by 800. That's exactly here 16 squares in the horizontal way and 8 squares here from the top to the bottom. So each square here has exactly 100 pixels. When we explore the panorama, then finally we can say exactly how many pixels we get here from this resolution. If we normally go with a 360 by 180 degree panorama to work and we want to have it one time around, and we want to have maybe something that works really in production for HD even, then we have to think maybe about 20 times the resolution. We will see. I have saved this here to make it easier as 1600x 800 or 16 times 800. And so we can see exactly what we get in the following exploration of our resolution. And I want to tell this here up front. When we use textures for objects, for backgrounds, for panoramas, for whatever we want to use, if the camera dodges or tilts or bangs, whatever you like to name it, in the moment we rotate things, pixels are not on top of each other, and when we move along very slowly, they are also not on top of each other. So it's more likely that one new pixel is calculated out of 4, which reduces the quality. And to work a little bit against this, the texture that we use inside of Cinema 4D should be at least 1.5 times higher in resolution than the final thing that we see. And what we see, that is what I want to show you right now when we hop over to Cinema 4D. And there I go to the material manager, to new material, and I double click this open, check off the other channels here, go to luminance and load here exactly this 1600 by 800 large image into it. I put this here inside of my folder. It's now in the text folder. And what I want to do here is, of course, normally to use immediately here the sky object, because that's an infinite sphere and any camera movement wouldn't show up as distortion. When I have a very small sphere, that would show up. Let's have a look how that works. But first of all, I want to go here with one sphere into the game, and I attach this material to it. And at the moment you can see from the outside the numbers are correct. What we see here is, of course, now 1600 pixels one time around and 800 in the 180 degree wrapping area, so to say. We can see that on the poles we have a much more dense area, but also much more distortion in it. We can see that we have here around this area, let's call it horizon line, 100 pixels up and 100 pixels down if we had a camera angle like this. You get already the idea. When we have a camera inside of this sphere, and I do this now just by calling one up, this looks now a little bit outside, so I use here my PSR option to set all the coordinates to 0 except for the scale, that should be on 1. And when I take a look now through this camera, I can see exactly this. And it indicates to me that the default setting of the camera here with a 1600 large texture results here in maybe 250 visible pixels. This divided by 1.5 to get the real resolution that I get really out of it is below 200. So I have 200 pixels here on my hand. And when I take a look, the default that I have here when I render the picture is 800. I can crank this up, of course, to whatever I like. And when I go here with film with 2K, then I can see here that I have maybe 10% of the needed resolution when I take the 1.5 rule into my mind, roughly set. Of course, the numbers are a little bit more accurate when you put this in a calculator, but here only to get an idea across. this is pretty blurry here, and that's not useful. And it's on the side, it's mirror sided. So let's go here to the texture tag, put a dash in front of the one here and flip this over. And what I wanted to show you here was, of course, that a sphere, when it's not very big, is very, very dischargeable. So when I go here very to the side, it doesn't make really sense. It looks horrible. Let's have a look how it works with the sky object. And when I drag now this material here over and switch the sphere off, you can see that I can't see anything because this sky object has no UV space, and this was set to UV, so I have to go here to spherical. And you can see I'm back into that space here. So the camera can be moved with the sky object in the same way, but we won't see here any change because it's nearly infinite in its size. And so any movement here with the camera will not change a lot. So the stability of the background is given with the sky object. And to make a sphere that big is maybe not a good idea. So I delete this here. That was nice to have for the moment, but the sky object is here really a little bit more advanced for our purpose. Again, when we have the camera here, we have a very specific focal length in conjunction with the sensor size. And when I change one or the other, I will change the resolution that we have. And you need to be aware that whatever you have here in the scene, alone based on the camera, is very dependent on this resolution. And I encourage everyone to go as high as possible with the panorama, of course in healthy sizes, to have the option to go maybe with the focal length a little bit longer. Let's say when I go here to 135, which is not a really long lens, it's a nice telelens. But then when I render this here, you can see here already we have here 25, 25, and this here is maybe 12.5 or something like that. So we have 75 pixels here, and we should divide this by 1.5 to get what we would get really out of that. And it's certainly not 2K here, it's more likely 50K, not even 50 pixels. And that is of course a huge, huge quality loss. So let's have a look. When we go here maybe to 50, which is considered a standard lens, and I have to here check a little bit where the real window would be for this 2K frame, Academy frame, so to say. And we see we have here roughly 2 squares, not really nearly. Okay, when I render this, then I can see that very clearly what we have. I say, please give me the final picture in 50%, so I have that here. It's not even 200 pixels, so it's way below 10%. So I can say 10% would be normally that we need to up-res the panorama 10 times. But we have also the need for the 1.5 into the formula. So we have 10 times 1600 times 1.5, which equals roughly 25,000 pixels, just to be safe, 24,000 of course. But in the moment we go a little bit closer to it, we change of course our reality already, and changes are always to expect. Whatever you do, there's a change. So we can say easily 1600 is way too low, 25 is maybe just very, very on the border of this quality here. And that's already a larger panorama. It's not really high. I think we have done 4 or 5 times the amount of pixels. But you have to consider that it's a huge file, and when you want to have it in 32-bit, for example, that's large, and it needs to be loaded, it needs to be calculated, and all of that. So to know exactly how this is calculated is of course a good idea to know before you even start to animate, before you even start to shoot. You can test this with your scene file here, of course, before you go out, and you can say, I need this amount of resolution, please shoot it a little bit bigger, because when you shoot in Panorama, we will see that later in the capture, in the workflow discussion, we lose quality based on the distortion that we get from the projection and so on. Longer scene. Okay, let's make another test, because we don't have the need only for background elements. We want to use it for reflections, of course. And we have to deal with pretty much 3 different cases: convex, concave, and flat. And they have the tendency to be not always the same, of course. Let's start just with a standard sphere, which is now exactly where the camera is. So let's move the camera a little bit outside, and let's pretend this is half of the picture frame. That's our main candidate here. It's a close-up. Okay, for that we need here now a material, because we want to talk about reflections. So let's make a chrome sphere here, drag this on it, and everything is done. Just render it so we can see how it works. And we stay here again with the 2K rendering. What I want to have here is, of course, a render to picture viewer. And we will get a result in a second. And I can tell you, of course, now what I think about this, but we can measure this. It's pretty simple. I go here maybe to 50 to show you the whole picture. I will save this file and I will meet you back in Photoshop. So I have our picture now in Photoshop, and now we can measure that. For that I go here into the info palette, and here I have a measurement. And I go here, of course, to my ruler tool, and now I want to measure that. I have done that before, so let's take this edge here. This should be 100 pixels in the reflection, and you can see here that we have here already 136 in the final resolution. That needs, of course, now the factor times 1.5. And then we have exactly the number that we need to cover this area here in the best way. This is a little bit less when we go to the border. It's then only 74. And we have even less when we go here to this area. But when we are interested mainly in getting a good result for the whole sphere here, then we have here to take 135 times 1.5, and then we know exactly how large one of these squares should be. And let's pretend that is pretty much 200, because we don't need exact numbers, we need only a sufficient resolution. Let's say it's 200 instead of 100 that we need here. That would result for this sphere, for this situation, for this camera setup, with a doubled resolution. We can see it's completely blurry in the background. Here it is sharp because it's much smaller, as you can compare that. And with 3200 we would have a sufficient resolution for this sphere. Except, of course, for these borders here, where it got really, really white here on the edges. There we might have a problem. But you will see, maybe always to have a little bit more than needed helps those edges here. Okay, let's do another test. For the next test I want to have, of course, the opposite direction, not convex. I want to have it concave. And for that I go here now into my hemisphere. And what I need here is, of course, a hemisphere that is oriented to the camera. With the shift key down I get this exactly. And I want to go here and make that really flat. So it's not as much as normally we would get with a hemisphere, just like a lens or so. The first test will show what we get here, and we will see this is now much bigger. I show you that then with 1. Of course, I think you want to see that. We get here huge areas, very large. And it's not really perfect anymore. So let's check out when it's relatively flat in the picture viewer. And that takes a moment. And now we can see here already we have pretty much 3 to 4 times the need for the resolution. We don't have even to go to Photoshop, and I go here maybe with A and here with B into the game, so we can count here already. We know already this here should be 200, so 1 square here is then pretty much 3.5 times, roughly said, what we had before. So instead of twice the resolution, we would have the need, when we have an object that gives me this reflection, pretty much then 7 times the resolution that we have. 3.5 here, 2 times here is 7, so 1600 times 7. That would be what we need here exactly. That's already a complete different animal. So last test was a flat object. The next one is then a flat object, and I want to see, of course, what happens. So I delete this object here, and I go here maybe with a cube into the game, so I can rotate this a little bit, so we can see from the start 3 different cases: very flat, half flat, and pretty much in the way it was before. It's not so much smaller. And I take here that reflective material to it. My first test might show that we have here a similar size, because when it's in the middle and the camera is not so far away from it, we should assume that the reflection of an infinite creates the same size. Let's check this out. It's pretty simple to prove. Here we take a plane, we put it to set, so ORC, and I move this here to the side, take that chrome material to it, render it, and it should be exactly the same. So this is now behind the camera, this is in front of the camera. It's pretty much the same. But it might change when this object here moves very far away, and we have to make this then very large. Maybe here too large to make any sense here. But I want to show you that, of course, what happens here. And it looks relatively the same. Let's move it to the side, more to the side. So it's relatively the same, because based on the sky here, we have that infinite, near to infinite distance. And so whatever I do here with huge values might not really make any big changes here. But flat means we get then relatively the same resolution like in the background. That might change, of course, from case to case. So it's roughly said, when the background is okay, flat objects might be okay. Concave and convex objects are a completely different animal, and you have to really make your tests with your own objects, because organic objects or whatever has a change inside of the curvature might create a bigger problem for the resolution. Last but not least, we have to check out as well something completely different, and that starts here again with a sphere, but this time with a transparent object. And there I can't really give you any advice. You have to test it on your own, because we talk about transparency and refraction. And that is a wide field. Whatever you think is the best way for your sphere here is maybe a complete different animal than with the glass sphere here, because it might change quite dramatically when you change the refraction values here. And then you can have all kinds of new scale problems here. That needs to be really explored. Any refraction can change the world dramatically. Okay, I think I have covered here the problem. I hope I have given you enough information so you can explore your own scene for your needs, what is really helping you and what is not working for you at all. And sometimes it helps to split up the reflection panorama with the background images. Sometimes the background images can be much smaller based on the camera move. That's, again, always an individual problem. You have to explore that, but I think you are aware of this right now. Thanks for listening. Have fun with it. Bye-bye.